The first examples we're going to talk about are grouping examples. The way you're going to be able to tell that a problem is a grouping problem is that it's going to have 4 terms. So you should always check for a greatest common factor first, but then if the problem has 4 terms, you're going to do grouping problem. And the reason it's called grouping is because you are going to put groups, use parentheses to make 2 groups, the first 2 and the last 2. And then essentially what we're going to do is 2 greatest common factor problems. So if you look at this first set of parentheses, so the x cubed plus x squared, they both have at least x squared. So I'm going to take an x squared out, and then left over, if we divided out x cubed by x squared, we'd have x left over. And then if we took x squared out of x squared, we'd have 1. And just in case you're not exactly crystal clear on what I'm talking about, we can think of it this way. So if I want to do x cubed and I'm dividing x squared out of it, I could think of it as x times x times x over x times x. So then we have this x and this x canceling each other out, and I'm just left with x, which is where this x came from. And then x squared over x squared, you'd have x times x over x times x. Everything cancels itself out. It's not a 0 though, it's just 1. So anytime that something cancels out or everything is taken away, you need to put a 1 to hold its spot. All right, for the second set of parentheses, we have a negative 6 minus 6. And you'll notice that I did include the negative in that second group. Whatever this first sign is, so in this problem I'm talking about this negative in front of the 6, whatever that sign is, that always has to be the sign of the number that you take out. And then if I look at both terms, I can see that they both have a 6, so I can take out a 6. Now what's going to happen here, I'm going to write it down, let's see, I'll use purple. Okay, so I have negative 6x minus 6, and what I'm doing is I'm taking out a negative 6. So what I'm really doing is dividing everything by negative 6. So if I divide negative 6 by negative 6, that cancels out and basically gives me 1, and all I have is x left over, so I would have an x. And then again, negative 6 divided by negative 6 gives me positive 1, so that's going to be plus 1. Now one thing you should notice is that I have 2 sets of parentheses, the things that are in blue that match. So I'm talking about this here and this here, and that should always happen. So if you are doing a grouping problem and those parentheses don't match, that means you did something wrong. So your final answer is going to have 2 parts. One of them is going to be the part that matched, which was x plus 1. And then the other part is going to be the things that you factored out as the greatest common factor. So your final answer is then this, x plus 1 and then x squared minus 6. For problem 2, we're going to do the exact same thing. And one thing I should mention, whenever you do any factoring problem, you should always be checking for a greatest common factor at the very beginning. Problem number 1 did not have a greatest common factor. It would have to be something that could divide out of all 4 terms. Same thing with number 2. I don't have anything that divides out of all 4. I could divide a 2 out of this term, and this term, but it can't divide out of the 5x, so it can't divide by 2, and all 4 terms don't have an x, so I do not have a greatest common factor to factor out, which we will in example 3 that you'll see. Okay, so the first thing we want to do is take the greatest common factor out of that first group. I can divide everything by 2 because 2 divides by itself and 8 divides by 2. And then I have x cubed and x squared, so I can take out the least exponent, so I can take out x squared. And then left over, we have to think of it like we're doing 2x cubed minus 8x squared, and we're dividing everything by 2x squared. All right, so here the 2's would cancel out, and I would have x cubed over x squared, so it's kind of like this one over here. It's exactly like that one. So we're just going to have an x left over. And then 8 divided by 2 turns into a 4, and it's minus 4 because of this minus right here. And then the x squareds cancel each other out. So I just have minus 4. I don't have to put times 1. That's unnecessary. All right, now for my second group, my first sign here is plus, so I'm going to have a plus sign. I can take a 5 out of both 5x and negative 20, so this is going to be my greatest common factor. And then I'm going to divide everything by 5. So if I take 5x minus 20 and I divide everything by 5, I would end up with x for my first, and then negative 20 divided by 5 is negative 4. Oops, I used the wrong color. So you see that the two sets of parentheses match, so that's half of my answer. And then the other half of my answer is what's written in green, which is 2x squared plus 5. One thing I do want to point out is that your answer does not have to be written in a specific order. So this answer here is perfectly acceptable, or your answer could be 2x squared plus 5 and then x minus 4. So it doesn't matter what order the factors are in as long as you have the right factors. All right, so last grouping problem. One thing that we need to always check for is a greatest common factor. So first I like to look and see if there are any numbers that you can factor out of every term. And that is not the case in this problem because 5 and 10, you could divide them both by 5, but then you'd have a negative 1 right here and then a negative 2, so that doesn't work. But if you look at the not the exponents, the variables, you'll notice that every single term has an x to the fourth, x cubed, x squared, x. So you can always take out the smallest of the exponents, which would be x to the first, which is this last one here. So before I start, I'm going to write this x on the outside of the parentheses, and then I'm going to divide it out, which means all the exponents are going to go down by 1. So this is now going to turn into 5x cubed plus 10x squared minus x minus 2. So now what's going to happen? I'm going to do all of my work using this right here. So this becomes my new problem. When I write my final answer, I'm going to have the x that I took out at the beginning, and then I'll have my two sets of parentheses that I get from doing what I underlined at the top. So let's go ahead and get started. I'm going to put this into a group. From the first group, I can take out 5 and 10 are both divisible by 5, and then x squared is the smallest of the two. So I can take out a 5x squared. In the parentheses left over, the 5 came out, and I took 2 of 3 x's, so I would have x to the first left over. 10 divided by 5 is 2, and I took out the x squared, so I don't have any variables with the 2. For the next group, I have to take out a negative because that's the first sign in that group. Now you'll notice that there's really nothing in common, so when that happens you want to put a 1 in that spot. You don't want to leave it blank because it's going to look funny then when you're trying to write your final answer. So we're going to put a 1 there, and what's going to happen because this is a negative 1 is it's going to flip all the signs of everything in the group. So if I think about if I divide by negative 1, when you divide by a negative, it flips the sign of whatever you're dividing by. So this is going to turn into positive x and then positive 2. So now I have my matching group of x plus 2, so that's half of my answer. And then I have my other group, which is everything that I factored out, so 5x squared minus 1. So my final answer is the x I took out at the beginning as a greatest common factor, and then x plus 2 and 5x squared minus 1. And again, it doesn't matter what order it's written in as long as you have all the correct factors. We're going to talk about two types of quadratic trinomials. This is part 1 because these are slightly easier. We're going to use what we call them diamond problems. They're not exactly a diamond, it's just an X really. And what you do is you put the last number here and you put the middle number here, and then you're looking for two numbers that multiply to the last number and that add to the middle number. And then the numbers that you get, so you're going to get a number here and a number here, those are going to be the numbers that you plug into your final answer. So your answer is going to look like this. It's going to be x plus whatever the number is, x plus whatever the other number is. Okay? So let's try one of these. So this first problem, and by the way, I should say, when we're talking about these quadratic trinomials where we use the diamond to solve them, First of all, it has to be a trinomial. That means it has 3 terms. And it has to be in standard form. So that means it has to go x squared x number. Okay? So it has to have 3 terms and it has to be in standard form. So for this first one, we would put 3 on the top of the diamond and -4 at the bottom. So I'm looking for 2 numbers that multiply to +3 and add to -4. Those 2 numbers are -1 and -3. So now my final answer, you always take whatever your x term is, your first term, sorry, your x squared term, and you break it in half, so each one would get x to the first, and then you just copy down your 2 numbers. So to be x minus 1, x minus 3, and this is your final answer. For problem number 2, the last number is -5 and the middle number is -4. So we're looking for 2 numbers that multiply to -5 and add to -4. So that would be -5 and 1. So again, we're going to write out our answer. We have our x in the first position of each group, and then we just fill in the numbers. So -5 and 1, so I'd have x minus 5. Since the 1 is positive, you'd write x plus 1, and that's your final answer. For this last example, we're going to do the diamond again. So I want 2 numbers that multiply to -42 and add to -1. So whenever you have a term like this, where there's no coefficient, it's a 1. In this case, a -1 because it was minus x. So the 2 numbers I would use would be 6 and -7. And by the way, it does not matter what order you put those 2 numbers in, as long as they're the correct number. So you could have written -7 and 6. So final answer is going to be x plus 6 since it's positive, and x minus 7. All right, so this is quadratic trinomial examples part 2. So all the same rules apply. You still have to have, it still has to have 3 terms, still has to be a trinomial, still has to be in standard form. The difference between part 1 and part 2 is that in part 1, all of your trinomials, the very first term was x squared. In part 2, all of the first terms will have a coefficient on x squared. So like over here, there's a 2 in front of x squared. So when you have a number in front of x squared, you're going to have to do a little bit of extra work. We're still going to use the diamond, but there's a little bit more we have to do. So I'm going to write this over here on the right side here. So the diamond, instead of putting the last term, so before we would have just put the 3 on the top, you're actually going to take the first and the last number and you're going to multiply them. So this would be the 2 times the 3. So I'm going to write first times last numbers. And then the middle number still goes on the bottom. So for this problem right here, 2 times 3 is 6, and then the middle number is -5. So I need 2 numbers that multiply to -6 and add to -5. So the magic numbers here would be -2 and -3. So the diamond part is almost the same, except that to get that top number, you have to multiply the first and last numbers. Okay, so now what we're going to do is we're going to write it out. Now before I said that we like split it in half, so you split that first term in half. We're not going to do that. What we're going to do, we're sort of doing that. We're still going to have 2 parentheses. What you're going to do is you're going to write the x, but you're going to leave the 2 with both of them. Okay, so I know that this isn't right yet, because if you multiply those out, you get 4x squared, so that's not right. But we're going to fix that. So I'm going to write 2x on each side, and then I have -2 and -3 that I filled in the parentheses. Now, at this point, this is our last step, we're going to divide out any GCFs. So any greatest common factors. So if you look at the first set of parentheses, you'll notice that they both have a 2. That means that's a greatest common factor. I could divide out the 2. So if I divided both of these things by 2, I would end up with, those cancel, x minus, those cancel, so I'd have a 1 left over. And then my second set of parentheses did not have a greatest common factor. So I just copy that one down, and that's my final answer. All right, so we're going to do the diamond. The top has to be 3 times 24, which is 72. And then the middle number is 22. That goes on the bottom of my diamond. This one is going to take a little bit of trial and error. You might have to divide 72 a few times to find the correct numbers. I will tell you that those correct numbers are 4 and 18. So if you multiply 4 times 18, it gives you 72. If you add 4 plus 18, it gives you 22. So now what I'm going to do is I'm going to take my 3x. So remember, I don't do x squared in each one. I do 3x in each one. So I split the x's and I use the 3 in each set of parentheses. And then I'm going to have plus 4 and plus 18. Now we need to look for greatest common factors. 3 and 4 do not have any greatest common factor. 3 and 18 have a greatest common factor of 3. That means they can both be divided by 3. So my first factor gets copied down, 3x plus 4. And then my second factor, 3 divided by 3 cancels out, and I just have x. 18 divided by 3 is 6. So this would be your final answer. So let's go ahead and do the diamond. In the top of the diamond is going to be 6 times negative 14, which comes out to be negative 84. And then the middle number, which is negative 17, is at the bottom. So I'm looking for two numbers that multiply to negative 84 and add to negative 17. Those turn out to be negative 21 and 4. So now what I'm going to do is rewrite my parentheses here. So remember that I'm using 6x in each parentheses. That's my first term in each one. And then I'm going to do minus 21 and plus 4. So now I'm looking for greatest common factors. This one is a little different than the first two. They both have a greatest common factor. 6 and 21 are both divisible by 3. So that would give me 2x minus 7. And then here, 6 and 4 are both divisible by 2. So this would give me 3x plus 2. So this would be your final answer.